What is the ratio of rotational and translational kinetic energy? The rotational kinetic energy represents the kinetic energy with which the sphere is rotating. Translational kinetic energy represents the kinetic energy with which the sphere is moving forward. When we divide rotational and translational kinetic energies, the resulting ratio gives us an idea about a special condition called as rolling without slipping. As discussed in the earlier section, rolling without slipping is a condition in which the sphere has two types of kinetic energies: translational kinetic energy and rotational kinetic energy. How to find rotational kinetic energy from translational kinetic energy? The translational kinetic energy is given by the formula K equals 0.5 mv/2. Rotational kinetic energy is given by the formula RK equals 0.5 IW/2. To find rotational kinetic energy from translational kinetic energy, we follow the steps given below. First, we convert linear velocity to angular velocity by the formula V equals W dot, or then we convert mass to moment of inertia by multiplying square of radius of gyration with the mass. This way we have moment of inertia, I, and angular velocity, W, so now we can find rotational kinetic energy. Describe the relationship between rotational kinetic energy and translational kinetic energy. In this section we shall discuss how both of these kinetic energies are related to each other. The only difference between them being the type of motion followed by the object. So let us see the relationship between them in the section below. Rotational kinetic energy is proportional to moment of inertia, which is rotational analogous to mass. Likewise, the translational kinetic energy is also proportional to mass. Also, they both are proportional to square of velocity and angular velocity respectively. Are rotational and translational kinetic energy equal? The rotational kinetic energy in most cases has a different magnitude than translational kinetic energy, although they can be same in some cases. When the radius of gyration is equal to the radius of rotating object, preferably ring, then we can say that the rotational kinetic energy and translational kinetic energy are equal. Practical examples of this are wheels of bike and cycle while coming down a slope. Is rotational kinetic energy less than translational energy? Yes, the rotational kinetic energy is always lesser than or equal to the translational kinetic energy. This is because the ratio of radius of gyration to the radius of rolling body maximizes at 1, which is for a ring or hoop. We have discussed the formulae of rotational kinetic energy and translational kinetic energy in the above sections of this article. We can find their ratio by dividing both the formulae with each other. Let us discuss more about the ratio in further sections of this article. What is the ratio of the translational kinetic energy to the rotational kinetic energy when it reaches the bottom of the ramp? When the object reaches the bottom of the ramp, the surface starts becoming horizontal. At this position, the value of ratio of rotational kinetic energy and translational or linear kinetic energy will be as per the information given in the section below. After dividing the formulae of translational kinetic energy and rotational kinetic energy, we get the following ratio: 2/5. This is the required ratio, that is ratio of translational kinetic energy to rotational kinetic energy. How much fraction of the kinetic energy of rolling body is purely translational and rotational? If the body is following a rolling motion without any slipping and the surface on which it is moving is horizontal, then the ratio of linear kinetic energy to rotational kinetic energy is 2:1. The required value is calculated by dividing the two formulae discussed above, one of translational kinetic energy and other of rotational kinetic energy. Hence we can say that the translational kinetic energy is twice in magnitude of rotational kinetic energy. What fraction of the total kinetic energy of a rolling sphere is translational? Let us assume that the sphere that is rolling is solid. The moment of inertia for a solid sphere is given by 2/5 Mr. 2. After finding the respective values of translational kinetic energy and rotational energy, we add them. To find the value of total kinetic energy, we can simply add the values of both the kinetic energies. When we divide the values of total kinetic energy of this rolling sphere and its translational kinetic energy, we get the ratio as 5/7. Can an object have rotational and translational kinetic energy? Yes. We can see multiple examples of the same in our everyday lives. A moving object can have both the types of kinetic energies, that is rotational and kinetic. The most common example of the above case is a wheel or sphere rolling. When an object is following a rolling motion without slipping, it is possible for it to have both the types motion, that is rotational and translational. Most common example regarding this is wheel. A wheel rotates as well as moves in a straight line motion, implying that it will have both the kinds of kinetic energies, rotational 1 and translational 1. The ratio of rotational and translational kinetic energy of a rolling circular disk. The moment of inertia for a circular disk is given as Mr. 2/4. We can obtain the value of rotational kinetic energy after substituting the value of moment of inertia in the formula discussed above. Once we are done with dividing the values of rotational kinetic energy and translational kinetic energy, we will get our desired value. The ratio we get after dividing both these terms is 1:2. This has been already discussed in the above sections of this article. What would be the ratio of the rotational kinetic energy and translational kinetic energy of the rolling solid cylinder? The moment of inertia of a solid cylinder is 1/2 Mr. 2. After putting the value of moment of inertia, we can easily find out the value of rotational kinetic energy. After dividing the values of rotational kinetic energy and translational kinetic energy, we get the required answer. The answer we get is 1:2. That means the translational kinetic energy is twice the value of rotational kinetic energy of the solid cylinder. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.